All right, thanks for joining us for this unplugged session where we're going to be going over the top 10 AppSec trends that we see in 2021. My name is Brent Jenkins, Director of Product Marketing. Joining me today is Harley Adams, Senior Product Marketing Manager. In any annual trend list, there really should be few surprises. Most trends are just a continuation of what was important a month or even a year ago. So there's the ongoing shift where modern development is more dynamic than ever with increased velocity and complexity. These top trends fit into that modern development framework where security is developer-driven and focused on actionable results that enable digital innovation. Harley and I will kind of pass the baton back and forth a few times along the way to discuss each topic. But I also wanted to mention we have an accompanying trend report available for download right now on our website. So just a quick touch on the trends that we'll be covering today. We have DevSecops, container security, infrastructure as code or IAC, vulnerability management, SAST plus DAST, cloud native application security, API security, DAST with functional testing, open source prioritization, and hacker level insights. So businesses today continue to rely on data and applications to interface with their customers. We keep seeing tremendous growth in not only the number of applications, but also the increasing frequency of application releases. To keep up with this rapid pace, organizations continue to adopt DevOps practices and are still seeing quite a bit of success. Based on a State of DevOps report from Google, high-functioning DevOps teams are seeing 208 times more frequent code deployments. They're also seeing 106 times faster lead time from commit to deploy and over 2,600 times faster time to recovery than lower functioning or waterfall teams. Now, obviously, these are somewhat inflated stats since Google's really comparing the fastest performing teams to the slowest, but it's still hard to argue the overall success that organizations are seeing with continuous integration and continuous deployment or development. But in most cases, security is still left out, or maybe better stated, security is either left too late in the SDLC process, causing more friction, cost, and rework, or there isn't really a true layered defense strategy in place, like building in security requirements in the planning stages, or performing threat modeling, or ensuring your developers are enabled to use secure coding tactics, while also performing security testing throughout the entire SDLC, not just the end. But why is that? Well, many times it's still a cultural issue. DevOps practices encourage automation to achieve scale, but security has traditionally been manual, process-heavy, and gate-driven, which is the antithesis of automation, transparency, and speed. Further, developers are responsible for and even measured on delivering functional, high-quality code fast, but most developers aren't equipped with knowledge of secure coding. And finally, without the right processes and tools in place, security is generally just considered too noisy for the speed of DevOps. So that brings us to our first trend on the list. And really, it's one that is kind of the main driver of most of the other trends we continue to see in the industry, and that's DevSecops. You'll see here, we've chosen to highlight the message that AppSec equals DevSecops, because really, in order to not only compete in this market, but to successfully implement an AppSec program in modern development, this is kind of the new norm. AppSec teams will have less influence in SaaS tooling and the DevOps toolchain. Development organizations have pushed back for years, and this has caused many commercial vendors to offer hyper-convenient scanning. The challenge here, though, as many of these embedded security scanning tools discover a fraction of the vulnerability issues a more robust AppSec tool can find. But it delivers convenience and cost savings while helping organizations still check that compliance box. It's become a game of balance between speed and accuracy, ease of use versus depth of findings, and tools being tailored to the developers instead of the AppSec professionals. Cloud platform vendors are also offering security tools that make it hyper convenient for development tools to avoid using AppSec tools. For instance, Google Cloud offers Web Security Scanner that can be kicked off via API and is free to use with certain usage thresholds. Once again, this checks a low threshold compliance box at a low price. So let's move on to trend number 2, and that's container security. Just to give some context, even though I'm sure most of you already know, a container is a standard unit of software that packages up code and all its dependencies. Containers are a solution to the problem of how to get software to run reliably when moved from one computing environment to another. This could be from a developer's laptop to a test environment, from a staging environment into production, or perhaps even from a physical machine in a data center to a virtual machine in a private or public cloud. So what about container security? What process do you use to implement security tools and policies that will give you the assurance that everything in your container is running as intended and only as intended? This includes protecting the infrastructure, the software supply chain, runtime, and everything in between. Well, speaking of supply chain, there's a heightened awareness right now in the software supply chain with the SolarWinds hack last year, and even with Equifax and Struts in 2017. Well, containers are now the ultimate battleground here, as multiple software supply chains converge when building and deploying containerized apps. A 2020 report from the Cloud Native Computing Foundation noted that 92% of surveyed organizations used containers in production, and that's up from 84% last year. Security and risk management practitioners have to deal with container security issues around vulnerabilities and compliance. And so, based on emerging best practices, we actually, in the trend report I mentioned earlier, added a 4-pillar strategy around shifting container security left to really complement post-deployment runtime solutions. So be sure to go ahead and check that out. So with that, I'm going to pass it over to Harley to discuss the next few trends.
Thanks, Brent. I'll tag team in here right now and jumping right into it. Our third trend to watch is infrastructure as code, or IAC, security adoption. Let's start with what IAC is. I'll read the textbook definition here. Infrastructure as code is the process of managing and provisioning computer data centers through machine-readable definition files, rather than physical hardware configuration or interactive configuration tools. This is a big thing because IAC technology is being adopted more and more by organizations to allow for rapid provisioning and cloud deployment of environments. Some benefits listed here include speed, since infrastructure deployments are quick with less manual intervention, and transparency, since code can be checked in source control, and the infrastructure code serves as living documentation of the state of the infrastructure. Then consistency and reusability. IAC allows you to deploy identical infrastructure across the board, avoiding edge cases and one-off configurations, and ultimately the snowflake effect where everything is different. With the power of IAC comes the responsibility of managing security risks, which can be introduced if best practices are not followed. Poor security decisions result in the rapid and automated deployment of an insecure production environment that is ready for compliance violations and data breaches. Attention to detail becomes crucial when nearly everything about infrastructure deployment is automated. Performing manual security assessments is just not sufficient. Unfortunately, provisioning and managing infrastructure through code makes it easier to hard code secrets within it. Hard-coded secrets or credentials is a common malpractice that involves storing plain text credentials, such as SSH keys or account secrets within source code. This risk can enable unauthorized privilege escalation and lateral movement during a breach. It's very difficult to trace and contextualize hard-coded secrets in runtime environments. One mitigation approach involves IAC templates, integrating both static and dynamic analysis of IAC templates into the CI/CD pipeline alongside the rest of the application can provide a more complete view of the actual risk. However, delivering this new experience to developers requires the right guardrails, separating what developers can and cannot do. Our next trend is about how vulnerability management takes a step forward. Vulnerability management provides a comprehensive view of risk from applications and their supporting infrastructure. By aggregating all vulnerabilities from different tools and parts of an organization into a single view, organizations can provide more holistic AppSec analysis and reporting. This can improve prioritization and help prove that compliance requirements are being met. Development team leaders and executives mainly care about the risk of the environment. Tools that aggregate information from multiple sources and present that risk in a roll-up view have an advantage over tools that offer a limited or focused view of the software. There's pressure for AppSec tools to natively offer this functionality at enterprise scale. The example on this slide is from our friends at SaltWorks, who built SaltMiner as a way to deliver aggregated vulnerability information to their clients. Another aspect of vulnerability management is the development of standardized output. Software developers and security practitioners use a variety of solutions to form an overall picture of security and quality of their code, but then they have to process results in different formats. Serif is the static analysis results interchange format, as you can read on the slide, from the OASIS Open Standards Consortium. This is a standardized output format that allows organizations to more efficiently view, understand, manage, and ultimately address software flaws. This enables developers to comprehensively capture the range of data produced by commonly used static analysis tools, and then also reduce the cost and complexity of aggregating the results of various analysis tools into common workflows. And with that, Brent, I'll tag team it back to you.
All right. Thanks, Harley. So SAST and DAST are both used to identify software security vulnerabilities, but they work in very different ways. Many times we hear organizations asking which technique should be used. Or we already do SAST, so why should we do DAST or vice versa? So I thought I'd take a moment to address that first before we get into the actual trend we have here listed. First, SAST has several main advantages over DAST. Like, it's typically known as more of a shift left approach, having analysis available everywhere, including the developer desktop and CI/CD pipelines. SAST is usually easier to automate, scale, and automatically provides the highest levels of code coverage. And feedback is fast and provides the exact location of vulnerabilities and their cause. But DAST has advantages over SAST, like it analyzes the whole application as it runs within the full system environment. DAST looks inside the application and dynamically analyzes execution logic and live data. One of the biggest advantages DAST has over SAST is its language and source code independent. And it can also check memory consumption, resource use, verify permissions to ensure the isolation of privilege levels, and et cetera, et cetera. So both types of testing tools come with their advantages and disadvantages. But the real message is that they can complement each other, one type being used earlier in the software development process and one later. So we always say for the most comprehensive coverage, using SAST and DAST together should be used to detect the most potential vulnerabilities. So if SAST and DAST already complement each other, the trend is now how to truly integrate them. By layering dynamic analysis on top of static analysis, customers gain a valuable additional risk metric, which allows them to see more complete real-world risk pictures. While it's important to identify vulnerabilities early in the SDLC using technologies like SAST, it is critically important to create feedback loops that can identify when those findings surface in running environments via a DAST scan. An organization that identifies findings like cross-site scripting early in the SDLC and continue to detect those and issues in production can focus their training and development resources on addressing systematic problems. True SAST and DAST integration means SAST and DAST tools integrate into a single developer-centric platform with a single management console. Unified vulnerability management creates feedback loops. A unified application security vulnerability management platform is not only critical in terms of the simplified prioritization and triage workflows that it introduces, but also in terms of the patterns that can be gleaned from the data. More intelligent scanning really means DAST validation of SAST findings and DAST tuning by SAST results. Trend number 6 on our list is cloud native application security, requiring a continuous AppSec approach. The modern software stack includes cloud native elements of the architecture. CNFC defines cloud native as cloud native technologies empower organizations to build and run scalable applications in modern dynamic environments such as public, private, and hybrid clouds. Containers, service meshes, microservices, immutable infrastructure, and declarative APIs exemplify this approach. So AWS, Azure, and GCP dominate the market here. Each offers similar functionality and SDKs for interacting with the cloud infrastructure components, along with a further level of abstraction with serverless functions. While cloud computing offloads many tasks to the cloud provider, the end user organization retains responsibility for securing the data that actually goes into the cloud. This requires a continuous application security approach that fits a dynamic environment. SaaS rule packs should detect vulnerability categories specific to the cloud provider's frameworks and cloud native apps out of the box. Cloud native apps are increasingly incorporating infrastructure as code, like Harley talked about, to programmatically define the cloud infrastructure upon which they operate. So another trend is to expand IAC coverage to seamlessly detect not only configuration issues, but more complex structural, control flow, and data flow issues beyond the capabilities of basic IAC scanners. So now I'm going to pass the baton back over to Harley.
All right, I got it. So our next trend is around API security. APIs are a key part of digital transformation strategies and found in modern mobile, SaaS, and web applications. These can be customer-facing, partner-facing, and internal applications. API use is booming. Every vendor or analyst report shows explosive growth in APIs. For example, Google Cloud State of API Economy 2021 report says that API traffic for Apigee customers increased 46% year over year to 2 trillion calls between 2019 and 2020. Just as API use is growing, APIs are therefore a rapidly growing attack surface that can be overlooked by developers and application security managers. APIs have security challenges. For example, APIs expose application logic and sensitive data such as personally identifiable information, PII, and because of this have become increasingly a target for attackers. A simplified view of API security goes like this. Of course, I'm going to say to incorporate SAST in the DevSecops pipeline for each independent component. Then API security incorporates DAST scanning at both the component and the system level APIs where HTTP is utilized. The first step is attack surface discovery, which means providing the endpoints and parameters that constitute the API attack surface. That's the what. And in addition to the what, proper discovery also incorporates how the API is used, which is important for the business logic workflows and sometimes complex authentication at the system level of the API gateway. Moving on, the next trend is around another way DAST is shifting left. We're having some fun here with another AppSec acronym. Functional testing plus dynamic testing equals functional application security testing, or FAST. The goal with this is to create seamless, fully automated dynamic testing as part of DevSecops pipelines. The FAST approach to dynamic scanning enables integration into the CI/CD pipeline and detects dynamic vulnerabilities based off the customer's functional tests, whether that be Selenium, Cucumber, or any other technology that leverages HTTP to test an application. This FAST technology will allow users to test the most critical portion of their applications with sub 5-minute scan times without the complexity of setup and configuration. On to the next trend, Brent.
All right, we're nearing the end here with our last two. This one is around open source prioritization of findings. I just want to start off on this one by driving home the point that using known vulnerability components is nothing new. As you can see from the last two OWASP top 10 lists, A9 hasn't changed in almost 10 years. And we're expecting a 2020 top 10 update, so I'm sure that using known vulnerability components will still be on this list. There's a pretty obvious reason why A9 hasn't changed in so long. If we take a look at some of the statistics from various reports from Forrester, Sneak, and Sonatype, you can see things like 99% of code bases audited in 2019 contained open source components, and 82% of them had components that were more than 4 years out of date. Some more stats that are a bit alarming as well are the DevSecops community found 1 in 10 open source component downloads contained a known security vulnerability. There's been a 71% increase in verified or suspected breaches between 2014 and 2020, and 1 in 5 organizations experienced at least one open source breach in the last 12 months. While all this is alarming for sure, many organizations have been utilizing software composition analysis to offset these risks. There are numerous players in the market, from open source tools like OAuth Dependency Check to best-in-class enterprise tools like our partners over at Sonatype. But there's still a major challenge with software composition analysis, and that's where we focus trend number 9. How do you prioritize your open source findings? Like with SAST findings, manually auditing is a time-consuming process. Based on a report from Sonatype, on average, you will spend 20 minutes manually researching an open source finding, and the average application contains 38 open source issues. So if the average organization has 100 plus applications, which we know at an enterprise level probably is much higher than that, that could potentially lead to over 1,200 or more hours spent investigating open source findings that may not actually have any security impact on your application. Teams need to be able to focus on issues that are not only vulnerable, but also exploitable. So that's where trend number 9 comes in. Susceptibility analysis means quickly illustrating vulnerable components that are directly or indirectly being invoked and thus exploitable. Being able to prioritize open source issues saves time on investigation of known issues and even more time spent upgrading a library that has almost zero security benefit. At Fortify, we partner with Sonatype to accomplish this. Others are doing the same. The way that we collect methods and function signatures is based on the requests that we receive from Sonatype indications of known components. So as you request the Sonatype scans various open source components, we understand that for any of those particular known vulnerabilities that have had updates, meaning that they have been patched, we'll generate a signature for that function or method so that we can see the function is actually in your own custom code and that you're utilizing that vulnerable component of the dependency. This means you know not just that you have the dependency on your class path, but you've actually used it in a way that makes you susceptible to this particular vulnerability. Again, other organizations are accomplishing this same thing in their own various ways, as it's obviously a strong need in the industry. Knowing what to prioritize means reduced false positives, time and money savings with better data to make better decisions. For our final trend, I'll pass it back over to Harley.
All right. Our final trend here relates to dynamic scanning evolution. So this envisions DAS scanning evolving from classic vulnerability detection into more of a risk assessment tool. The idea is that so-called hacker-level insight technology will present developers and AppSec teams with the same set of data that a hacker would typically use to perform reconnaissance and targeting. Adding dynamically detected component and library reporting to DAST enables DevSecops teams to use this information to, quote, see what the hacker sees and in turn prioritize their resources toward the most critical gaps in their application security posture. Developers can use hacker-level insight to better inform their threat model. Okay, that was our top 10 AppSec trends for 2021. We hope you enjoyed it. This list came from us watching the industry and listening to our customers. And so with that in mind, we hope that you'll add your comment for any items that you might have included in a list of your own. And if you haven't already, please subscribe to our channel for future updates. Thank you for watching.